Hello, my name is Yulia, and today I would like to talk about how pre-trained models, in particular BERT, encode different linguistic features for typologically different languages. Recently, there has been increased interest in cross-linguistic encodings and embeddings, and while this is a very amazing effort, we will need to approach this task very carefully, otherwise it's very easy to get entangled in different features encoded across different layers of pre-trained models. So we suggest that we should approach this task similar to how it's approached in linguistics, that is to do a pairwise comparison of languages which contrast in a particular feature which is related to the task we are interested in. So in particular, we choose several tasks here, and we choose languages which reflect particular linguistic features which is necessary for this task. For example, for the task of word order corruption, we choose languages which with fixed and free word order and contrast them, and in our case it's English versus Russian. Similarly, we for the same task, but to test how well the models encode different head directionality and different type of morphology, inflection versus agglutination, we choose Korean and Russian languages. And for the next set of tasks, we choose English and Russian for both of the tasks, and we mostly test for agreement in terms of number. So in the first task, we choose English as morphologically poor language and Russian as morphologically rich language in terms of plural agreement, and we check for long-distance agreement. And in the last task, we check for presence of gender bias in the language with forms, noun, adjective, verbs, and noun forms marked for grammatical gender, and such as Russian, and language without such marking, such as English. So we approach task using two main methods. For first two tasks, we use a so-called bigram shift classifier. To put it easy, we randomly swap two adjacent words in half the sentences and feed them into a classifier, which is a simple model consisting of frozen BERT layers plus a linear layer on top. And for this task, task 2 has some restrictions in terms of what kind of swapping we can do. So we, because we're interested in head directionality, we try not to cross the boundaries of a noun and verb chunk, and so there are some restrictions. For tasks 3 and 4, we use mask word prediction. So we mask a token, which grammatical form we are trying to predict from the context, and check whether the probability of some word form, for example, for task 3, it's going to be a word in correct number, and for task 4, it would be just a word in particular gender, is different from what we expect. So now I'll just go quickly through the tasks, and as I said, the results and details of training are in the paper. So in the first task, we would check how sensitive the models are to corruption in word order corruption in languages with fixed and free word order, and we hypothesize that it would be harder to detect this in Russian because Russian has a free word order, so theoretically the word can move around sentence much freely. And if you look at the results layer by layer, it is so at lower levels where the model encodes morphology. But as we move to the higher levels where model encodes syntactic features such as agreement, we can see that the Russian model actually outperforms because of all these different bindings and agreements a Russian language has. It becomes easier for a Russian classifier to detect the corruption. So task 2 was very similar to task 1 in terms of how it was structured, but here we were trying to test several things at the same time, because Korean and Russian both have free word order, but they contrast into different aspects. So first, Russian is inflected. So one grammatical particle simultaneously expresses several meanings. It can express words number, gender, tense, and so on, just using one particle, while in Korean you would use several particles for that stacked upon each other. And so in Korean, a natural unit for NLP is such a grammatical subunit, each of which expresses either a stem of the word or some particular grammatical meaning. While in Russian, like in English, a very natural unit would be a whitespace tokenized word. So we compared how difference in tokenization reflecting this typological structure of language influences the sensitivity to word order corruption, and also how they had directionality, so whether the verb precedes the object or follows the object, if it can be detected by the models equally well, because we thought that because BERT is unaware of right and left-hand context and treats them equally well, it should be similar in performance, whether we have had first or had final language. And it was so in the morphology levels. If you compare the results for models Code 2 and Russian, we can see then when we have tokenization at whitespace level, basically that is similar. So the model cannot detect if the word was moved to the right or the left. But if we go to the level of subunits, which are more natural for Korean, we can see that basically from the very first layer, there is extremely high performance in detecting the corruption. So if we try to move around these grammatical particles, it's very visible for the encoder. So for the next set of tasks, we did masks language prediction, as I mentioned, and we were trying to predict a correct number, and the hypothesis here was it would be easier for Russian because in Russian we mark many words for number, not just verbs, and there is a possibility that the contest between the cue and the target word we're trying to predict will include some clues which will have the correct number we need. And this was so, but if you can see, it was only on the last layer, and up to the level 12, the Russian model was underperforming, which shows that it takes a lot of time for the Russian model to actually learn all these different morphological and syntax relationships which are necessary for it to detect correct agreement. And lastly, for task 4, we did a similar task with masking, but of course there was no correct answer here. We were just testing how many female or male gendered forms are predicted by the model in the top 50 predictions. And so basically, overall, the results show that for Russian, the bias is encoded even more strongly than for English, and we would find that the model would highly prefer masculine forms even for professions which are not necessarily strongly associated with masculine gender in English, such as hairdresser. And if in English still there were there were no strong preference between choosing female and masculine form. For many professions, it was 50-50. For Russians, there was high preference in choosing masculine forms. It was over 90% of forms for pronouns and 100% of forms for verbs and adjectives were marked as masculine. And we suppose it's just because in Russian we mark all words for gender, and masculine gender is just more present. So the main takeaways here is that of course we have to make more comparison to make stronger conclusions, and this is a bit of a sandbox where we were trying to highlight how necessary it is to have a stricter design for cross-linguistic experiments, and we would strongly advise you to choose languages based on the task you want to perform and not just because you happen to know them. Thank you so much. I hope it was useful.